Good evening everyone. Today we have to learn the integrations of the algebraic rational functions. Now in this algebraic rational function, first we define what is meant by the rational function, and also for finding the integrations of such types of the functions, the partial decomposition of the partial fractions is most important. So in this lecture we learn the definition for the rational function, also the types of the rational function and the decomposition of the partial fractions. Now let us start. The first we define the definition of the rational function, and in the definition we consider, suppose the f(x) is a function and defined by the g(x) divided by q(x). Here we denoted this as the capital G(x), means in this case these types of the function is said to be a rational function. Here the rational function divided into the two parts, and that two parts are the here first is the proper rational function, and another type is that the improper rational function. And these two definitions are depending on the degrees of the g(x) and degree of the q(x). In the proper rational function we consider the degrees of the g(x) and the q(x), means the numerator and the denominator, such that in this proper rational function the degree of the numerator, means g(x) is less than degree of the denominator and q(x), means in the proper rational function the degree of the numerator g(x) is less than the degree of the denominator. Similarly, we define the improper rational function, and in the improper rational function the degree of the g(x) is greater than or equal to degree of the q(x). Now here, if in your function the degree of the g(x) is greater than or equal to the degree of the q(x), so first we divide this g(x) by the q(x) and find out the function such that the degree of the numerator is less than the degree of the denominator. So for such cases we directly divide g(x) by the q(x), and your rational function in this case is the f(x) is equal to the the g(x) divided by q(x), but if the degree of the g(x) is greater than or equal to the degree of the q(x), so we write this as the suppose q(x) plus the r(x) divided by the q(x). Now in this case this small q(x) is the quotient of this function and the r(x) is the remainder. Here this is the remainder, and this remainder, and the degree of the remainder is the less than this q(x), means we write the rational function in the case of improper rational function, the f(x) is equal to the q(x) plus r(x) divided by the capital Q(x), where small q(x) is the quotient of the function and small r(x) is the remainder of the function. But we remember that the degree of this Rx means the remainder is less than the degree of the Qx means your denominator. So, your improper rational function is converted in the form of the proper rational function. This is very important for finding the integrations of the algebraic rational function. Means in the integration of the algebraic rational function, there must be a function is a proper rational function, and we see if there is a improper rational function, so first we divide the functions and find out the function in the form of the Qx plus Rx divided by the Qx, where Rx is the remainder, small qx is the quotient of the function, and the degree of the remainder is the less than the degree of the your Qx means the this term is in the form of the proper rational function. Now, for finding integration of the algebraic rational function, the second part means the partial fractions is also very important, and the partial fraction means the here the Qx means the denominator, and the partial fraction is depending on this denominator, actually the factors present in the denominator. Now, we define the decomposition of the partial fractions of the rational function, and that time we consider your function fx is equal to the your rational function fx equal to the, we can consider here the, suppose I consider that function is the fx is equal to the px divided by the qx or gx divided by the qx, any one, but we remember that the function is of this type is said to be the rational function, and the next part is the partial fractions, and partial fractions are depending on the factors of the denominator. So, there are the many types of the factors in the rational function, and here we discuss about the cases or the types of the factors present in your rational function. Now, first type is the non-repeated linear factors, means here we consider the case 1, and in the case 1 we consider the non-repeated linear factors, in denominator. For this type, the function fx is in the form fx is equal to the px plus the q divided by x minus a multiplied by x minus db, means here the function is the rational, and also this rational function is the improper, because in the numerator there is a polynomial containing the px plus the q, means a degree of the x is the degree of this polynomial is the 1, and in the denominator there are the two factors, but these two factors are the different, because one factor is the x minus a and another factor is the x minus b. Such types of the functions or such types of the factors are said to be the non-repeated linear factors in the denominator. Now, these types of the factors are present in your function, that time we consider the decomposition of these factors is in the form, if in your integral or in your function there are the two factors, so we consider the two unknown constants, and that constants are here the capital A is a constant and we write that two unknown constant in the form A divided by x minus A plus B divided by the x minus B. This is the composition of the linear non-repeated linear factors in the denominator. Similarly, if in your example there are the 3 factor, so we consider the another constant divided by the that factor. Now, the second case is the repeated linear factors in denominator. And in this case the function is defined f(x) is equal to the here the px plus the q and divided by the factors are the suppose repeated linear means the x minus a and that repeated this suppose 2 times. So, the decomposition of these partial fractions is in the form, here is a one factor x minus a, that the linear factor but repeated 2 times. So, the decomposition is in this way. We consider in this case also the 2 unknown constant a and b, but we arrange that constants in the form a divided by x minus a plus the b divided by x minus a bracket square. If in your example suppose there is a cube means x minus a factor repeated 3 times means here repeated 2 times. Similarly, suppose your function consisting of the 3 factor linear factor but repeated 3 times. So, we consider the decomposition is in this way, a divided by x minus a plus b divided by x minus a bracket square plus c divided by x minus a bracket cube, means this is the decomposition of the partial fractions in the case of repeated linear factors in the denominator. Now, we consider the third case, and third case is I write here third case non-repeated, and your first case is the linear factors in the denominator. So, I consider here the case third, and your case third is the non-repeated quadratic factors in denominator. Now, in this case the function is of the type f(x) is equal to the, suppose I consider here also the px plus the q divided by the quadratic factor is present, means the degree of the factor is the 2, and so the function is of the type x square plus the a, means here the degree of this x is the 2. So, this is the quadratic and this factor is the single times. So, this is a non-repeated quadratic factor in the denominator. Now, here the factor is the quadratic, so consider the 2 unknown constant, and the decomposition of this factor, this quadratic factor is in the form this is the same, means we consider here the capital AX plus the b divided by the x square plus the a. Here a and b are the unknown constants. Find using the method for comparing the numerators and the denominators, and we find out the values of the capital A and the b. Means if we have to ask the integrate the rational function, and we have to given that the function is of the type the non-repeated linear factors in the denominator. So we consider the decomposition of the linear factors in this way. If in the case of the repeated linear factors in the denominator, so we consider this type of the decomposition. And in your example, in your denominator the quadratic factors are present, so we consider the such type of the decomposition. Sometimes in the example we have to given that the example is of the type, for example we consider the example is of the type, the suppose 2x plus the 3 divided by x minus 1 square, x minus 2 is the single and another factor is suppose the x square plus the 2. And if we have to ask integrate this example, integrate this function with respect to the x. So we first check the degree of the numerator and the degree of the denominator. If the degree of the numerator is less than the degree of the denominator, so we directly consider the function for the partial fractions, and the partial for the partial fraction we consider these three cases. And in this example the x minus 1 is a linear factor but repeated 2 times, x minus 2 is the linear factor but the single time, and the x square plus 2 is a quadratic factor and is a single factor. So this example is of the type of these three cases, means this example consisting of the non-repeated linear factor in the denominator, repeated linear factor in the denominator, and also the quadratic factor in the denominator. So we consider the combination of these three cases, and we consider, or here we write the decomposition of these linear factors in this way. Means for the decomposition we consider your function 2x plus 3, x minus 1 square, x minus 2 and the x square plus 3. Here we have to given that the 2 multiplied by the, we consider only the function for the partial fraction. And using your second case, means non-repeated linear factors, we consider the two constants and arrange the factors in this way: a divided by x minus 1 plus b divided by x minus plus b divided by x minus 1 square. Next is the x minus 2 is the factor, but that is non-repeated. So we consider the next unknown constant c divided by the factor, and that factor is the x minus 2. And we consider your third case for the quadratic factors in the denominator, that the x square plus 2 is the factor, and your decomposition is such that we consider the next constant, and the next constant is the d, and we write this as the dx plus the e divided by your quadratic factor, and that quadratic factor is the x square plus the 2. Means we use the decomposition of these partial fractions of these types of the factors present in the denominator. So we consider this type of the decomposition. Now in this lecture we see the what is meant by the rational function, types of the rational function, and for finding the integration of the rational functions we have to there is the most important thing is that the decomposition of the partial fractions. So we see that three types of the partial fractions, and the partial fractions of the factors present in the denominator, and that three cases are the non-repeated linear factors, in the denominator, repeated linear factors in the denominator, and quadratic non-repeated factor in the denominator. Also we see if there is a combination of the non-repeated linear, repeated linear and quadratic factor, so we consider also the decomposition of the partial fractions in this way. Now in the next lecture we will see the particular cases for this integration of the algebraic rational function, and that cases are depending on the factors present in the denominator.